Aristotle's Cosmology and Geology. Aristotle's cosmology depends on the basic observation that while bodies on Earth either rise to a limit or fall to Earth, heavenly bodies keep moving without any apparent external force being exerted on them. DC 284 a 1015. On the basis of this observation, he distinguishes between circular motion, which is operative in the superlunary heavens, and rectilinear motion on sublunary Earth below the Moon. Since all sublunary bodies move in a rectilinear pattern, the heavenly bodies must be composed of a different body that naturally moves in a circle. DC 269 a 210, meteor. 340b615. This body cannot have an opposite because there is no opposite to circular motion. DC 270 a 20, compare 269 a 1922. Indeed, since there is nothing to oppose its motion, Aristotle supposes that this fifth element, which he calls ether, as well as the heavenly bodies composed of it, move eternally. DC 275b15 2125. In Aristotle's view, the heavens are ungenerated, neither coming to be nor passing away. DC 279b18 21 282 a 2430. Aristotle defines time as the number of motion, since motion is necessarily measured by time. Phys.224 a 24. Thus, the motion of the eternal bodies is what makes time, so the life and being of sublunary things depends on them. Indeed, Aristotle says that their own time is eternal, or eon. Noticing that water naturally forms spherical droplets and that it flows towards the lowest point on a plane, Aristotle concludes that both the heavens and the earth are spherical. DC 287b114. This is further confirmed by observations of eclipses, DC 297b2331, and that different stars are visible at different latitudes, DC 297b14, 298 a 22. The gathering of such observations is an important part of Aristotle's scientific procedure, AMPR.46 A1722, and sets his theories above those of the ancients that lacked such experience, Phys.19 1 a 2 427. Just as in his biology, where Aristotle draws on animal anatomy observed at sacrifices, HA 496b25, and records reports from India, HA 501 a 25, so in his astronomy he cites Egyptian and Babylonian observations of the planets, DC 292 a 49. By gathering evidence from many sources, Aristotle is able to conclude that the stars and the moon are spherical, DC 291b1120, and that the Milky Way is an appearance produced by the sight of many stars moving in the outermost sphere, meteor. 346 a 1624. Assuming the hypothesis that the Earth does not move, DC 289b67, Aristotle argues that there are in the heavens both stars, which are large and distant from Earth, and planets, which are smaller and closer. The two can be distinguished since stars appear to twinkle, while planets do not. Aristotle somewhat mysteriously attributes the twinkling stars to their distance from the eye of the observer. DC 290b14, 24. Unlike earthly creatures, which move because of their distinct organs or parts, both the moving stars and the unmoving heaven that contains them are spherical, DC 289 a 30b11. As opposed to superlunary, eternal substances, sublunary beings, like clouds and human beings, participate in the eternal through coming to be and passing away. In doing so, the individual or primary substance is not preserved, but rather the species or secondary substance is preserved. As we shall see below, the same thought is utilized in Aristotle's explanation of biological reproduction. Genet Core. 338b620. Aristotle holds that the Earth is composed of 4 spheres, each of which is dominated by one of the 4 elements. The innermost and heaviest sphere is predominantly Earth, on which rests upper spheres of water, air, and fire. The sun acts to burn up or vaporize the water, which rises to the upper spheres when heated, but when cooled, later condenses into rain, meteor. 354b2434. If unqualified necessity is restricted to the superlunary sphere, teleology, the seeking of ends that may or may not be brought about, seems to be limited to the sublunary sphere. Due to his belief that the Earth is eternal, being neither created nor destroyed, Aristotle holds that the epochs move cyclically in patterns of increase and decrease. Meteor.351b519. Aristotle's cyclical understanding of both natural and human history is implicit in his comment that while Egypt used to be a fertile land, it has over the centuries grown arid. Meteor.351b2835. Indeed, parts of the world that are ocean periodically become land, while those that are land are covered over by ocean. Meteor.253a1524. Because of periodic catastrophes, all human wisdom that is now sought concerning both the arts and divine things was previously possessed by forgotten ancestors. However, some of this wisdom is preserved in myths, which pass on knowledge of the divine by allegorically portraying the gods in human or animal form, so that the masses can be persuaded to follow laws. Met.1074a38-B14, compare meteor.339b2830, pol.1329b25. Aristotle's geology or earth science, given in the latter books of his meteorology, offers theories of the formation of oceans, of wind and rainfall, and of other natural events such as earthquakes, lightning, and thunder. His theory of the rainbow suggests that drops of water suspended in the air form mirrors which reflect the multiply-colored visual ray that proceeds from the eye without its proper magnitude. Meteor.373a32, 373b34. Though the explanations given by Aristotle of these phenomena contradict those of modern physics, his careful observations often give interest to his account. Aristotle's material science offers the first description of what are now called non-Newtonian fluids, honey and must, which he characterizes as liquids in which earth and heat predominate. Meteor.385b15. Although the ancient Greeks did not distill alcohol, he reports on the accidental distillation of some ethanol from wine, sweet wine, which he observes is more combustible than ordinary wine. Meteor.387b1014. Finally, Aristotle's material science makes an informative distinction between compounds, in which the constituents maintain their identity, and mixtures, in which one constituent comes to dominate, or in which a new kind of material is generated. See Sharvey, 1983, for discussion. Though it would be inaccurate to describe him as a methodological empiricist, Aristotle's collection and careful recording of observations shows that in all of his scientific endeavors, his explanations were designed to accord with publicly observable natural phenomena.